Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Everyone, welcome back into the program. Today on the show, we have the one, the only Mr. Ralph Bond, where we'll be talking about anything and everything related to science and technology trends, as that is, he is our correspondent for that, and we're really looking forward to that. Now, I want to say to everyone, and obviously, kind of been talking about all week, but ladies and gentlemen, the website is still down. Today's Friday, and of course, our episodes are available on YouTube and, all the podcasting services and stuff like that. But the website itself, and of course, social media is still up as well. But our website itself is hopefully back up today. So fingers crossed, we'll get that working. And when that is up, you'll find show notes, articles, reviews, contest giveaways, and of course, past shows, future shows, and really links to everything. We put a lot of work into that, and you should definitely check that out when we have it up and running. And sometimes it is actually just that, up and running. But ladies and gentlemen, with that being said, why don't we go ahead and bring on our guest and just get things started here, because I don't know about you guys, but between the heat waves over in the UK, all the stories coming out of the conflicts in UK and Russia, or UK, wow, Ukraine, not UK, Russia, and there's been a lot of pessimism lately, ladies and gentlemen. I can't think of anyone better to take us into the weekend than Ralph Bond himself. So Ralph, welcome back onto the program. How you doing?
I'm great to be back. And gosh, talk about heat in the United Kingdom. I just can't imagine what those people, well, in France too, and all of Europe, but the bit about it's so hot that the rails are warping, the train rails.
Really?
It's just unbelievable. And the tarmac at the airports, the bubbling up of the asphalt, and just like, I can't, those poor guys, hang in there, folks.
Yeah, no kidding. But we're of course here to talk about a number of different stories, and these are, going to be very, very cool. Some of them we kind of touched on last week, which is story number one, which we'll jump into that in just a second.
Right.
But Ralph, why don't we go ahead and tell the nice folks out there, if this is their first time, what it is that you try to do here with our segment.
Yeah, sure. Ben, of course, I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets. I scan everything every day. I'm obsessed. Mm-hmm. And I look for important and sometimes kind of wild and wacky out there stuff like story number 2 today that don't usually capture mainstream press attention, or not at all, in fact. And I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. It's kind of all over the board. And what I do with each news item is present the essential points in what I hope is a digestible form. And I stress to our audience to check out the show notes that you post with links and so forth for the articles, so you can get a deeper dive if you want. And if your website, by the way, Ben, is down, people can always come out to my website later today. I'll have that up and available as well. It's just Google my name, Ralph Bond. Just Google Ralph Bond like the spy, and you'll usually find my link right away, and takes you over to my website. Well, you'll see my KEX radio work and my Computer America stuff as well. So as a fallback, there's where you can find today's show with me.
Right.
So there you go. That's what I do.
Yeah. And of course, if you're following along with the video segment, there's your website as well, which, right there, you got, pictures, and of course the PDF right there looks great.
Right.
Looks perfect. So ladies and gentlemen, definitely, that one is at least working. So perfect.
So far.
But also the video portion is going to be helpful because we'll be, going through the articles, showing videos, stuff like that. And I think a good way to go about this, Ralph, is to just jump right into story number 1.
Yeah. Okay. Story number 1 kind of picks up on where we left off last week, and has to do, of course, with the James Webb Telescope And in specific, the bit about the announcement, everyone was so compelled or so absorbed by the images, and rightly so. They were spectacular, right? Everybody was so focused on that a lot of the news services and so forth kind of just a little tiny check mark about what we're going to focus on, which for me, I think was one of the most compelling things released last week. And that is that the telescope detected water, clouds, and haze on a giant planet more than 1,000 light years away. So that's kind of our headline here. And first started with a story on CNN, and then also went to NASA's website and their postings about this. And they talk about steamy atmosphere. So anyway, so again, as we said last week, we talked about the images. And I said what really blew my mind was the telescope's ability to analyze the atmosphere of a giant exoplanet. Exoplanet, folks, is any planet outside of our solar system, okay? So the atmosphere of a giant exoplanet called WASP-96b. And it's not, truth in lending right now, it's not NASA saying that this is a white Anglo-Saxon Protestant planet. No, I don't know what the WASP stands for. It'd be fun to kind of find out. But this planet, this absolutely melts my mind, is located 1,150 light years away. And remember that a light year is approximately 6 trillion miles. And so it's actually 5.88, but I rounded up, okay? So that means that this planet that the telescope was looking at, so to speak, is approximately 6,900 trillion miles away. I can't go there. That's just too weird.
Very far.
So let's get into what's going on here. The purpose of the telescope's atmosphere analysis is to look for possible biosignatures, which include water, oxygen, or methane, that could indicate life on the surface of a distant planet. And that, to me, has always been something I've been so interested in. It's just so fun to speculate that life, something like we understand or know, could be out there, albeit 150 or 1,150 light years away, but nonetheless could be there. Yep. And here's how the telescope was able to analyze the atmosphere of this faraway planet. So the telescope's enormous mirror and precise instruments joined forces to capture the most detailed measurements ever recorded of starlight filtering through the atmosphere of a planet outside our solar system. And a light spectrum analysis of the different wavelengths of the starlight passing through the atmosphere. So let's stop for a second. Here's what's going on. It's the starlight passing through the atmosphere that's going to be analyzed. This is how they pulled this off. So the starlight passing through the atmosphere enabled scientists to identify a distinct signature of water along with evidence of clouds and haze. So it's a light spectrum analysis of light passing through the atmosphere of this incredibly far away planet. So the analysis, which revealed the presence of a specific gas molecules based on tiny decreases in the brightness of precise colors of light, is the most detailed of its kind to date, again, demonstrating Webb's unprecedented ability to analyze atmospheres hundreds of light years away. In this case, remember, 1,150 light years away. So here's the other thing that's so cool. In addition to detecting water, the light spectrum analysis capabilities of this telescope will enable scientists to also detect potentially and measure the presence of carbon and oxygen and even estimate the temperature of the atmosphere. And of course, the telescope will be able to do the same for many other exoplanets in the future. So, wow, it's just so, everything about James Webb Telescope is so hard to really fully comprehend and absorb and deal with mentally.
Right. Yeah. And of course, you get this chart here, which scientists know, can probably make a lot better sense out of this than we could. I got to say, though, NASA has, not squandered their budget. They've done some outreach to the everyday people like us, Ralph, where, right here, this is also on NASA's website, and you can actually explore some of the exoplanets. And it's this is WASP 96b, and they actually do a little CG rendering of
Isn't that bizarre?
Yeah, and of course of the system where, Ralph, this is a system with one star and one planet so far that they found, but that's really all there is to it, and it's a gas giant, and you can see it right there. Very, very cool what they're doing with with this.
I know.
So from Ralph from dots and kind of dots on a graph to actually being able to see what it should look like. That's very, very cool.
I know. I love it. Yeah. And again, that brings up a good point, Ben. Everybody, please, if you're interested in this, check out what NASA has posted online, like Ben's showing us. They've done a great job. Good for them.
Yeah, definitely. And one last thing before we move on from James Webb, because that'll be kind of it for our segment here with that. But I do want to say that this came out this week, Ralph, and I don't know if you heard about this. This isn't really a story that you'd really cover, but the hard drive that is on the James Webb Telescope. Take a guess how big a hard drive is, because these images are massive. These images are so detailed, massive. It's, really incredible what they're sending back. And of course, it just got up there. It must have a huge hard drive, right?
You would certainly think. So whip it to me. What do you got?
68 gigabytes is the entirety of the hard drive on the James Webb Telescope. It's a 68, very tiny. Very tiny.
Yeah, it must be just a pass through. It's got to be a pass through scheme where it's just there as a temporary reservoir as it's beaming back the data. So it's like a streaming pass through instead of a retention thing.
You are exactly right.
Yeah, and the other guess I'll have is it really a mechanical spinning hard drive, or are they talking about a solid state? Because it occurs to me that it would be terribly risky to put something that's electromechanical in this job, right?
No, you're dead on the mark a second time. It is a solid state drive, 68 gigs, and it has been radiation hardened because, space has to do with a lot of radiation. It has some special enclosures, and Ralph, exactly you said again, it orbits the Earth, 2 times every day, and every time it kind of reaches a certain point, it beams back the contents of its hard drives back to NASA. So
there you go.
So every day it collects about 100 gigs, and it sends that back twice a day. And of course, I think a lot of people out there may just think that this is something cutting edge, and it really is, but 68 gigs, that's a tiny SSD, and it's really doing an amazing job for what it is. So amazing what they can do with our technology. Mm-hmm.
And then one more thing, I wonder if that data entering into that solid state drive is compressed to help compensate for the small capacity. I wonder.
I'm sure that absolutely it's compressed to a certain point, because Ralph, like the images are really one thing, but a lot of what you see with NASA, like this is a lot of the data that they're collecting, which is just points on a graph and red shifted, and the really non-visible spectrum, and then the pictures that we get, Ralph, are what NASA does. They take their scientists and they take their artists and they recreate what the data says that we're looking at.
Very cool.
It's really, really cool. So there you go. Story number one, which is always fun to visit James Webb. That's going to be Ralph. That's going to be a fixture for like the next 10, 15 years, 20 years on Computer America. I'm looking forward to it. Story number one. Story number two, though, we're going to get a little bit more back down to earth, and we're getting really personal inside our mouths, to be exact. So story number two.
Yes, this one's fun. And it seems wacky in the category wacky, but at the end of the story, you'll see where I think it's potentially very important. Anyway, so the headline here is, someday tiny robot shapeshifters may brush and floss your teeth for you. Okay. I've got this from a couple of sources. First, futurism.com. And then that spurred me to go out to the University of Pennsylvania and look at their announcement for this. Really, really fun, wacky story. And if you're looking at the image, folks, yes, the teeth in this image definitely need some help. They look not so great. Anyway, okay, so here's the story. A group of researchers at the University of Pennsylvania has developed the ultimate no hands dental care in the form of a swarm of shape-shifting microbots that can treat and remove bacteria and plaque from your teeth. And I want to stop for a second and say something about this. When we think of robots, right, I think of things like the Boston Dynamics robot dog or humanoid type robots or robotic arms in manufacturing. And that's what I think of when I think of robot. They're using the term robot here in a much broader embracing envelope of possible meaning, because we're not talking about robots like the robot dog or a robot humanoid or a robot construction arm or anything like that. We're talking about particles that are manipulated remotely, hence they're robotic. Okay. So you need to kind of expand your thinking about what is a robot, right? So with that said, the teeth cleaning microswarm is primarily made up of tiny iron oxide nanoparticles. So those are really tiny little guys. And because iron oxide is magnetic, these minuscule nanoparticles can be manipulated into shapeable structures using a magnetic field device. And that's illustrated in the picture that goes along with this article. And by controlling the magnetic field, the researchers at the University of Pennsylvania were able to transform the iron oxide mini-bots into bristle and floss-like shapes that can be moved to reach every dental nook and cranny in your mouth. In fact, they can form bristles that can extend, sweep, and even transfer back and forth to emulate flossing. And the tiny iron oxide mini bots aren't just magnetic, they're also catalytic, with the ability to generate bacteria-killing and plaque-degrading free radicals by activating hydrogen peroxide. And that I'd like to know a little bit more about. That seems pretty wild and crazy, right? And this may seem like, and here's my point, this may seem on the surface like a kind of a weird science stunt. It's like, okay, yeah, that's cool. So what? And there's other questions too I'll get into in a second. But this could be a real blessing if it hasn't already occurred to you. For those with disabilities who cannot clean their own teeth, imagine someday that kind of capability being available to those folks. But here's my question that wasn't addressed in the article, and I couldn't find it's addressed clearly. What kind of device would you have to have? Let's imagine someday we're at home. Maybe you're a disabled person, or it doesn't matter, and you have these. How do you introduce these particles first into your mouth? And then what is the device, the magnetic field control device? Is it something that's going to sit in front of you? Does it first have to do a scan of your face and analysis to, look at your teeth and figure out? Well, think of it this way. If you have one of those Roomba robotic vacuum cleaner things, right? The first thing that happens is it goes around your house, exploring the house and getting a map of your home. Well, you would have to do something like that for the mouth for this to work, and then program it. And what is this device? Is it something that sits in front of you on an armature? A whole bunch of additional questions. And again, let's be honest, folks, this is early research. We're not talking about a finished product that you're going to go and get at Costco or Walmart or whatever. So give it a chance here. But that just spun up a lot of follow-up questions in my head about how would this be a deployable commercial product someday.
Yep. And of course, the images that you were talking about earlier with the not so healthy, teeth, that's really as far as the testing has gone, is, they've kind of mounted the teeth to look like a human mouth. They've never tried this in it. Rob, in my mind, I'm thinking something like those mouth guards, and, sometimes they use them in the dentist office, they use them in sports and stuff like that. Maybe, have everything kind of encapsulated in that, and then electromagnets, and flip a switch and have it all good. That obviously, you would think that you wouldn't want to swallow this, but because I guess they're just iron oxide, that's perfectly fine. It's okay to eat that. Just don't eat too much of it. This is very, very cool. And like you said, expand your idea of what a robot is. I don't know, Ralph. Brushing your teeth is like one of those things that I feel like has not really gotten better in like 1,000 years. Like, the toothpaste has gotten a lot better. Fluoride in the drinking water is really good. All of that kind of thing. People's teeth are healthier than ever, but it still feels so barbaric that, we still just kind of have to scrub. I'm hoping this comes out for everyone. I just want everyone to have easy, healthy teeth. And
and it overcomes the laziness factor.
Yes. Yeah.
Or may help.
2 to 3 times a day, whatever your dentist recommends, it's a pain in the butt. So I'm all for robots automating that. There we go.
Yes,
Story number 2.
too.
Story number 3. And
Yes.
this time we're going with a different type of battery. Ralph, in the past we've talked about advancements in lithium ion and switching to different materials. This is what we're hitting at again.
Yes. I couldn't resist this. And it's a very interesting website too, autotech.news. It was the first time I had pulled a story from them. And check it out, folks, if you're interested in the auto industry and technology. It's a very cool site. So the headline here is Future Electric Vehicles May Use Low-Cost Sodium-Ion Batteries instead of good old lithium-ion batteries. And again, comes from autotech.news. So, of course, Ben, we all know that the overwhelming majority of our electric vehicles today, they use lithium-ion batteries. But sodium-ion battery technology, an alternative that's been on the sidelines for many years, may now finally become a viable and more environmentally friendly alternative. And the environmental friendliness has to do with the source materials and the manufacturing process. So right off the top, the big appeal of sodium-ion batteries, no surprise, is that the chemical element, good old sodium, in contrast to lithium, is cheap and, of course, abundant, right? Sodium's a component of what we call in our homes table salt, right?
Yep.
When it comes to manufacturing a car battery, a sodium-ion battery is nearly identical to a lithium-ion battery, with the key difference being sodium compounds are used instead of lithium compounds. The point of that paragraph is that when you're looking at saying to the car industry or to the industry that makes the car batteries, we'd like you now to switch over to sodium ion. The objection could be, well, wait a minute, you're asking me to retool a whole different manufacturing process. Not really. It's pretty painless. It's just a swap out of the certain components. It's not a big tear down and redo your factory kind of deal. That's the point of that paragraph, which is also adds to the profoundness of this potential here. But here's the problem. To date, the limited longevity performance of sodium ion batteries has hindered their large-scale use by automakers. That's been the problem. Drum roll, but here's the good news. Thanks to a research team at the Department of Energy's Pacific Northwest National Laboratory in Richland, Washington, that barrier is falling. And of course, I live in Oregon, as many of the listeners who've been with us for a long time know. And so it's super fun for me, especially to think here we are, our cousins up in Washington State have pulled this off. This is really cool. So by using an ingenious shift in the ingredients that make up the liquid core of a sodium ion battery, the Pacific Northwest National Laboratory team recently announced that they greatly extended the performance and longevity of this battery technology. And a little qualifier, a little truth in lending, they published this result, they promoted it, but they stress that this is in controlled laboratory tests and so forth. So they're not talking about a battery they put in a car and put out on the road. Or this is really early, but very, very promising. So the research findings provide a promising recipe for a low-cost battery solution that may soon power electric vehicles. And of course, being batteries, could help store energy from the sun. For example, batteries that collect energy from solar panels, maybe on your home or business or whatever the case may be. So there's a lot of excitement here about the possibility of getting batteries much less expensive to make because of using sodium instead of lithium.
Yep, and according to and of course, according to the article, they're trying to refine and reduce the need for things like cobalt. So, maybe one day it's just a couple of basic ingredients, including, salt, and hey, you have an effective, long-lasting battery. Ralph, that would, and honestly, energy storage, that's a topic that we've talked about before, where if you can store energy and just save it for when you need it without, killing the environment or polluting everything, that would change the world. Like that is really incredible. So best of luck to the team, because this would change so much, so much. And I love to hear it because it could even be used on things like story number 4 that we're going to get to. But it can be used with anything, and that's really amazing. So
I love it.
Great stuff, Pacific Northwest. And Ralph, story number 4.
Yeah. So story number 4, kind of takes us also in the transportation zone, sort of, kind of. So a key trend to watch: cargo ships with high-tech rigid sails. And I got this story from cleantechnica.com. And it's not so much that it's a brand new story, because you can see the date there is 2021, but the tail end of 2021. But I just got onto this whole idea, and I just thought this is so interesting, even though it's not a fresh this week story. It's a trend. And there's other people involved with this, as well as the company we're going to talk about here in a moment. So again, cleantechnica.com is a source. You can see that if you're looking at the images, it's really kind of fun to check out these rigid sails. But here we go. Recently, not so recently, a French startup company, Zephyr and Bory, unveiled plans for a cargo container ship decked out with huge rigid sails designed by an outfit called Computed Wing Sails. And their website's fun to go and visit as well. And it's a good example, latest example of a trend that's gaining interest in the shipping industry. Because you can imagine with the cost of fuel, how the big cargo ships, oh my gosh. Every time I go down the street to the gas station, I look at the price for regular gas, and then I look at the price for diesel, and your mind just melts at the expensiveness or how much more diesel costs. Yeah. Anyway, I digress. So this ship that's in planning stages will be 677 feet long, with a capacity to carry 1,800 20-foot cargo containers. So each of the large vertically mounted rigid sails is a structure that resembles the curved wing of an airplane, or really more like a glider. And like a glider wing, the rigid sails have an asymmetric profile with an extremely high lift to drag ratio, leading to optimal propulsive force generation, of course, meaning as the wind strikes the surface. And to adjust to changing wind condition, the sail structures can fold down to half their height for optimal wind power efficiency. And that's shown in the illustration that we have with the notes here. And this is a cool part, because you could say, well, okay, it's nice to add these rigid sails to my ship. It's going to help fuel economy and all that good stuff. But do I need additional crew members, specialists on board? Answer, no, because controlling the rigid sails does not require any additional crew members, as the positioning and operation settings are entirely computer automated. So there's an onboard computer on the ship that takes care of all of this. It's constantly analyzing the conditions and adjusting. It reminds me of last week's story about the sailplane, the autonomous sailplane for Mars, that has a computing system that's constantly monitoring the wind conditions to adjust its flight pattern. Well, the same kind of thing is happening here with these rigid sails. The computer is constantly monitoring the wind conditions. It's going to say, hey, the wind is really, really strong. I need to fold my sails down in half. Otherwise, we're going to have a problem, et cetera, et cetera. You get the picture. And here's another thing that's kind of interesting. The sails meet the robustness and reliability requirements called for by the maritime regulations for commercial ships. So they're going to pass the laws that govern how these things are put onto ships and certified and so on. And the bottom line, basically, and no surprise here, by combining wind-powered rigid sails with traditional fossil fuel-based propulsion, this cargo ship is expected to produce 30% less carbon dioxide than a conventional cargo ship of its size. So that's the payoff. If you can imagine the world's fleet of cargo ships putting out 30% less carbon dioxide, that's a significant contribution to fighting climate change, I would say.
Yeah. No kidding. It's really incredible what these sails might be able to do. They look so strange, Ralph, because whenever I think sails, I think, of course, big cloth sails. But these things look so futuristic.
Yeah. And the other thing, Ben, to think about, and I was saying this to Mark Mason yesterday for our segment here at KEX in Portland. Right. I said, wait a minute. When we've had issues with fuel economy and cost and expense, and just think about good old capitalism, making more money. Why is it taking so long? It's only been in the last couple of years that people go, hey, I know, let's put sails back on our ships. To me, it's our ancestors were onto this, for thousands and thousands of years. And wow, I just kind of blows my mind that all of a sudden now it seems to be this kind of groovy trend in the cargo industry.
Well, and I was showing an image on the screen just a second ago. It was this one.
Yeah.
Ralph, this is
That's
the answer
great.
to that question, which is, why not? Because, ladies and gentlemen, oil and gas and coal for the last 100 years has been so abundant and so cheap that filling up your ship full of diesel and letting it push itself across the ocean was so effective and cheap. You didn't have to worry about the winds. You didn't have to do anything. It really didn't matter. And Ralph, I honestly believe, even with oil prices where they are, and all of us have to go fill up our car, and we know gas prices are crazy right now. It's still cheaper to do gas. It takes real legislative and direction and push from everyday people to get goals like this. That short-term measures to reduce CO2, 50% total reduction by 2050, and steps to eliminate them completely by 2050. It's little things like that, Ralph. Like, capitalism is great and it will push so much so fast, but at the same time, gas is cheap and we need actual action, I guess, is my response to that.
And you know what, talking about economics, if you will, on this kind of proposition,
of course.
I'm assuming that you don't have to start from the ground up and build an entirely new ship to embrace and use these sails. If you look at the illustration, you can see they're on mounted armature like things, a base, the sails. And so it seems to me, could it be possible to take an existing cargo ship and with a little bit of modification, put these sails in? Of course, the computer system would go on the ship and kind of, okay, away you go, right? Can you retrofit an existing cargo ship? My gut tells me yes. That's kind of interesting. And another thing, you think about the history of this business of going from good old cloth sails and rigging and all this sort of stuff to propulsion. It was first with steam, right? Yeah. So steamships and coal used to fire the boiler and make the steam and run the engine and all that good stuff. And at that time period, when steamships took over from sail ships, the big economic thing that occurs to me, and I'm guessing about this, is that suddenly the shipping industry people went, great, we don't need to have highly skilled, highly trained sailors who know how to operate the big rigging. I mean, that was a skill. That was a very specialized skill. And so now suddenly I don't need those guys anymore. I can just load up this thing with coal, get the water, and away we go. So there was a huge economic advantage to getting rid of sails. Hence why at that time period, the age of steam sailing, the sails went away. And it would still be true today if you had to have specialists. That's the point of this technology. This is automated. It's high tech. It's computer driven. And one of the reasons why maybe we didn't put sails back on cargo ships or other forms of ships prior to the computer age was just that. It would mean specialized human beings.
Right.
Now you have this ability to kind of make these computer controlled things that I hope can be retrofit, that can be put on existing cargo ships as well as from new. So it's an interesting area to think about and watch this trend go. And there's other people out there doing this stuff. I want to mention this too at the end here.
Sure.
This is not the only effort to put sails on cargo ships. Check out what a company called BAR, B-A-R Technologies, a British company. It's fun to read their website because it's so very British, was going with its wind wings. And you can see that in the image there in the show notes. Wow, those are huge sails. I mean, that's some big stuff there.
Yeah.
I kind of wonder how realistic that is because the scale of those sails is so enormous. But nonetheless, they've already secured 2 signed contracts to work on new vessels combining wind wings with hull optimization for customized solutions. So again, this is not just this one company that we talked about. There are other people in this game, and I believe it's coming. I think it's going to be so interesting to see this and how cool. I remember flying into Los Angeles earlier this year, and out the window of the plane as we were approaching LAX airport from the ocean, just hundreds of these ships sitting out there waiting to go in. And someday, wouldn't it be cool to see them with their big sails?
It's really cool, and I'm trying to remember the article that we did like a week or two ago about special cruise ships that were using, I guess, like a battery or
hybrids, hybrid ships,
the hybrids to get in and out of ports much more efficiently. I mean, all these little technologies, while I was kind of talking to you, Ralph, I found this other article, which for time's sakes, we're not going to cover. I'll actually send it to you. Maybe you can use it in next week's, but,
I love it.
This article, which if you're watching the video, you can see the title. If you're listening, not going to say it because it might come up next week. So
send it to me. I love it.
This was part of this article, which is Mission Innovation. I've never heard of them before. But, ladies and gentlemen, to give you a little bit more hope, and then we're going to get out of here, this is an organization dedicated to reducing 60 gigatons of of greenhouse gases, carbon emissions, and things like that. And you can see here that they cover everything from space, living, nutrition, health, personal development, social skills, all this kind of thing. Ralph, there's so many people and companies doing good work, trying to help people and solve the issues that we all keep hearing about every day. We're going to get there, Ralph. It's just, we need that optimism. We need to keep trying and pushing. And if we can do our part to get our word out about these great companies doing this, I'm happy that we do this every single Friday.
Amen.
All right, perfect. So everyone, with that being said, we're going to start the music and we are out for the week. And everyone, we hope that you have a great weekend. You do something fun. Everyone out there, stay cool, stay happy, and hey, we'll catch you back here next week with hopefully, again, today we'll have the website back up. Worst case scenario, Monday we'll get it back up and it'll be a little bit lighter. And hey, maybe even load a little bit faster because some stuff won't be on there. But everyone, we'll catch you here next week. Have a good one. Bye-bye, everyone.